Okay, hello again. And let's continue my journey learning SIG. Where did we end up yesterday? I think the last thing we did was this branching on types. Just gonna verify branching on types. That's correct. Cool. Then we have function parameters in SIG can be tagged as being comptime. This means that the value passed to the function must be known at compile time. Let's make a function that returns a type. Notice how the function is PascalCase as it returns a type. Okay, so we have try, expect, yes, test, matrix, giving an initial value, and it should be of this type. Let's make a function that returns a type. That's special. Sorry, we got cats, and there's cat hair everywhere. Let me just this one. So this would give us the type, but this wouldn't say anything about the content of this. So we have a matrix, we give it the 3 parameters. Is that just the order of which they're declared, that it's gonna be? Yeah, I guess it is. No, it's it's a function, not a struct or something. So you just have a function that takes 3 parameters and returns a type. That makes perfect sense. And the type is height, width, and type. Nothing special there. Where to use this, I'm not really sure. We can reflect upon types using the built-in typeInfo, which takes in a type and returns a tagged union. This tagged union type can be found in standard library built-in type info on how to make use of imports and stdlib later. Yeah, but we already done that multiple times, right? Yeah. This is how it's imported. So here we have a function called addSmallInts, and we have a test where we call it with U16, and this returns a type. It doesn't return any information. So what does this do? It's gonna switch on the type, comptime integer. Oh, so if it knows it at compile time, it just adds the 2. If it's a normal int not known at compile time, we can take that information. If info.bits is less than 16. Yeah, but what does this do? Does it just count the number of bits needed to represent the number? And if it's less than 16, it returns the value, the sum of the values. Else, int's too large because the sum can't be fit into. No, then we would check against the, not just the int, but am I missing something? We need to play with it. Because I would, if we were checking this, I would check to see if a plus b fit into this one, not just this. But what is this? What is info at this point? We need some debug output. I'm pretty sure we can't add print statements inside the switch. But I think we can do something like this, right? No? Maybe? We can maybe say value like this, and then the type. I think we shouldn't add anything in the formatter here if we want to print out this one. Once again, I can't. Just switch. What are you on about? No field name comptime. Okay, before we're gonna change anything, let's just accept the original and see if it actually compiles. It does not. It breaks because it's no field name comptime. So this might be something that has changed from version 0.13 to 15. Because I would expect it to work in the tutorials here. Error no field name comptime int in enum typeInfo built-in type dot union tag. So where does this come from? We're checking on typeInfo type, and that's just the U16, or is it this one? We could try to remove these two and just stash the X and see if that works. No, it already breaks at the first one. Okay, when the examples doesn't work, I get a little bit iffy about learning something from something that I'm not sure about is right. I hate learning something the wrong way and then later having to unlearn that to learn it the right way. So I think I'm just gonna skip this one because apparently this is not there anymore. Maybe we should just try to say 14 and see if the example is the same. addSmallInts. See, it's not the same. Let's try this one. and see if that works. That just isn't seen as a test. It's so weird. See, now that works. So maybe it's just that they changed the naming. But yeah, as I'm running sig 0.15, I think that was what we concluded at some point. So just sig version, yeah, 0.15.2. This hasn't been updated, and that's okay. But now we can take a look at this. Sorry. Yeah, my trimmer for my beard, it broke, so I have a bit of a long beard compared to what I'm normally used to. So hairs get everywhere and it tickles. Okay, back to this. We wanted some more information about what was going on. So let's redo that. See if we can do this, this. A plus B dot T for the type. This for type. Let's see if that works. Again, I still can't just click the non-existing play button out here. No, it's not there. I have to right click and run test. And this is what's weird, because this is known at compile time. So this should be run, but there's no output. And this is what I find a bit weird, right? Why can't it just figure out that I want to have outputs? So this is run. But this too is run, right? As this is known at compile time, this should be run. Compile time. Just gonna do the same for both, just to see if that is what I'm missing here. Runtime. Now, why won't it? Oh, this. Again, I've been working with a language where we don't need the semicolon. So I have to remember that, switching back and forth. No. But why is that giving an error now? Error value of type 16 ignored. So it would be so much easier if we actually had the debugger running. Then we could just set a breakpoint and conclude what's happening. Oh, thank you, Jesper Guber. I would say that without the beard, I look like a 12-year-old, so the beard helps, and it also hides the double chins and so on. So I think it looks better with, but a bit long right now. So what's going on here? Why is this not working? Should it always just have a return value? And does it mean that in switches, the last thing you set is what is being returned, like in other languages? What does it actually say down here? It says value of type U16 ignored. But why is that being ignored? I think it's being returned like just before. Save. No. What the actual? Does it really have to be this rigid? But we can't have this? Oh, how was it? There, we don't need it. Comptime. Something's off here. What did I do? Info 16-bit. Else. Okay, I changed something, but I can't actually see what I changed. I feel like I haven't changed anything. Oh, I did, didn't I? I just need to remove that one and then this one. Save it. And let's try running it again. Nope, still no. Or is it having to run twice? Oh. Curly brackets gone. And now it will work. Yes. So it actually doesn't like the curly brackets. I would say that this shouldn't change anything. Oh, there's an if statement here. Can we redo everything? Yes, we can. Oh, redo, redo, redo. We want it with this version. We just need to have this one moved to before the if, and this if includes this else, right? If this else, but we don't have another if. What's going on? Am I really this blind? We can't have multiple else's. This if yes, of course. We need to have this. So if this is fulfilled, this will run, else this will run, and then we have the else for what? For this one. So this should end with a dot, right? No. This is this is kind of funny. It should be such simple code, but it isn't. If we had indentations, I would be able to see this, and then that this was there. Do we need to do no comma? Yes. See, indentation actually matters. Let's try again. God knows which time. And it still breaks. Damn it. Value of type 16 ignored. This time in line 15, it's this one. But why is it being ignored? It should either return this or this. Compile time error, but we are not handling errors. We're only returning a type. Can we check on type error? Oh, it's just compile error, compile time error. So this won't even compile. So what is actually going on here? Okay, let's see if we can get any of these running. We probably can't because it's failing on the first line as I read it. That's the only one where we call this function. But why is this not possible? Value of type U16 ignored. All non-void values must be used. Assign it to. Yeah, but I don't want to discard it. I want to return it. Do I need to do something like this? But then it would just return true, right? Because this is possible to set. I'm pretty sure this would just... Yeah, found void. Expected use 16. Now that function returns, but it returns void because this doesn't return anything. And I guess I can't just do this, right? Or maybe I can. Maybe it's just, if you have it like a single line, it returns. But if you have it in a block, you have to return something out of the block. But whatever, it works. And let's add a return new line to this and to this. I know that it will add some extra lines in there, but it will make it a bit more clear. Yeah, this is runtime, value 50, and a U16. But again, I think this is not okay. I think that actually should be A plus B. Or what? Oh, A is of type T, but we get the values. So I feel like, what is this info? Can we just get that? What is this at this point? Info? Because I actually don't have any clue because I'm still not used to reading this syntax. info. Okay. Is it an info on int? Signedness. Unsigned. Number of bits 16. So we can actually get information about an int. So int covers all the different types. Unsigned 16. So if we say signed and just test for signed. Yeah, signed 16-bit. Let's take 32. 32. Ints too large. Need to update this one. Yeah. Sorry, just a second here. Thank you. Whoa. Back to this, back to this. Okay. What's a bit confusing is if it's a compile time int. What defines a comp? Is it the comp time? So now I'm forcing it to do this at compile time. No. Call it compile time here, log standard error writer. I think that's something to do with this and compile time. So let's just remove this, and see what it's. Then it just says okay. Can we somehow see some more information about this? We are adding these. So if I do this, it should still work because we never. I thought that we were never hitting this, so it wouldn't be an issue. But apparently it's because we are calling this one at compile time, so we can't have this. But why can't we have standard debugging output at compile time? Oh, at compile time. It would be nice if we had some output at compile time. So when we compile, we could still get some feedback. Line 14. So it is this one. Okay, moving on. It would have been nice to get a deeper understanding of this. But again, just from this, having the ability to get information about an integer, get if it's signed or not signed and so on, the size of it. Can we get some more information about? Oh, type is a union of everything. Yeah, makes sense. Doesn't take up memory. And the struct for an int is if it's signed and the number of bits in a U16. So it can have a lot of bits. It's a type. Data structure is used by the SIG language code generation and therefore must be kept in sync with the compiler implementation. Yes. We have the same for floats as bits. Pointers have, oh, size, this const volatile, address space. Oh my god, that's a complex thing. The pointer, and arrays, comptime length. Yeah. Okay, back to back to this. So this makes sense, but not completely, because I looked like I couldn't hit this one, and I would like to know what actually is the difference, how to hit this one. Or did we get it working just by doing this? But at this point, I have no clue if it's running this code or this code. I was hoping that it would be this code, but I'm not sure how to evaluate and see if it's actually, yeah, I could change this one. So now I would expect 40 if it was running this one. And it is not. So still 50. Yeah. Okay, so it's not hitting this one, even though we remove the comp time. Let's try 40 again. Nope. Nope, nope, nope. If not okay, return test. Now I've broken the test itself. Great. Let's remove all this and go back to having just this. And let's try again. Nope. Fails on this one. Yeah. So even though I add the compile time, comp time, to this one, that doesn't change this, because this type isn't a comp time type. Can I add comp time to this one? No. So what is a comp time int? So I could switch on it. Moving on, we will learn this if we ever need it. You can use the type function to create a type from a typeInfo. Type is implemented for most types, but is notably unimplemented for enums, unions, functions, and structs. Here, anonymous struct syntax is used with the, but this is the, oh, what was it called? I don't remember. And yeah, this is the array of something. Because the T in T of this can be inferred. Anonymous structs will be covered in detail later. So they call this kind of anonymous structs. In this example, we will get a compiler error if the int tag isn't set. Well, let's try. And suddenly we have this error to run the tests. So this test works. So what's going on here? Get bigger int give it a U8, and it should return a U9. So we have the type. If the type is an integer, bits. Again, we have these two variables on this, and we create a new int from this information. And as we saw before, right here, the struct is signedness and bits. So it looks right. So we give it a number of bits and the signedness typeInfo of type.int.sadness. Again, this is just foreign to look at. But we get the typeInfo of this, but that should be int. So, but this contains all types. Comptime t. typeInfo for u8.int. This part, because as I would understand, this type we know is an int. We already inferred that one. So can't we just take the signedness of this? No, we cannot. No field named. Okay. Then I'm not sure what this is actually returning. typeInfo of int. Let's dive into that one. So we have a test. No. Close that, please. Oop. And let's do an experiment and see typeInfo of an U8. typeInfo. Let's see what it says. typeInfo. See, it does have this information, but it also has this. So typeInfo contains this information. So it actually contains the full information about the type. So that's why we need the dot int, just to get to here. This int is equal to this. So we get this, we access the int info, and then the signedness. It's a weird word, signedness. But okay, that makes sense. We just take that information we just had from the old one, and we build a new one based on that information. So that makes perfect sense. Perfect. Again, where would I use it? And just the idea that we can have a U17 or 5 is just weird. Again, I would like to know how it is laid out in memory, because if we have a U5, would that be 8 bits long? Or would it be 5 bits long? I think it would be at minimum 8. But that's something with memory layout and so on. But this makes perfect sense now. So if we take a float, There's nothing called an F8. 32. Yes. Now this will fail, that's for sure. I'm not even sure that you could... No? Oh yeah, because I didn't change anything. This is just the output. It's a float. It has 32 bits. But we can't have this. What if we call this with a... No, get bigger int. We are not handling the floats in here. Anyways. So this makes perfect sense. Returning a struct type is how you make generic data structures in SIG. The usage... Sorry. Yeah. It's been a rough night. Returning a struct type is how you make generic data structs in SIG. The usage of this is required here, which gets the type of the innermost struct, union, or enum. Here std mem equals is also used, which compares to slices. Oh, that was slices I was talking about before. As I remember, this is also called a slice. So that's a big example, but let's take it one step at a time. Generic vector. We have a vector of 3 of type float 32. We init it with an array of 3 32-bit floats. And we take the absolute value of x and try to check if it matches. So this code makes perfect sense. But how is it implemented? Oh, we have something called comptime int explicitly. So I could have used that in the other test down here. This one. So if I have said comp time 20, comp time 30, now this should fail, right? It still doesn't fail. Why not? I can say comp time I32. But you know now this is comp time later. Comp time T. Can I? Everything I give it is now marked at comp time, but still it doesn't hit this one. Because this would return 40 and not 50, so this should fail. Yeah, I don't get that one. But let's take a look at this one. So we have a comp time int. I have to figure out what that means compared to anything else, because in my mind, this is what defines an integer that is known at compile time and can't be changed as it's known at compile time. Then we have a comp time type, and we call it T. Struct, the data, the amount of data, and the type. So self is this. why use this instead of, is that just some caching to use that instead of having this? Yeah, apparently it is. So this is just caching of this. What does this actually do? This is a type. Return the innermost struct, enum or union that this function call is inside. This can be useful for an anonymous struct that needs to refer to itself. When this is used at file scope, it returns a reference to the struct that corresponds to the current file. So this, what is the type of this? Is that vect, or what would it call this type? I need to know. Declarations are not allowed between container fields. This is structs. Let's look at self. Whoa. Why is it being annoying? Why is it being annoying? Thank you. Nope. Okay. That's just weird. Again, why can't I just access stuff and print it out? It's quite annoying when that feels like it's the only way to output stuff. Maybe it's because I'm trying to output a decimal. Thank you. So this is a, what was it called? Struct syntax, anonymous struct, slice. So this contains data. It contains itself and the data. So it contains this, but not the self. That's okay. And then we do a temp self data equals undefined. So it makes a new vect t based on itself with no data. Then for each data element with index from 0 to whatever is needed to go through all the data, it takes the element and the index, access or sets the temporary data index equals 2. If element is less than 0, then return the negative value, which then would be positive, else return the positive value, and then return the temp value. So it creates a new vector and adds the data from itself. That also makes good sense. And then we have an init. Data, the number of elements in the array of that type, returns a self type. It returns itself. Return self with data equal to the data. And the data is in there, and it's defined the same way when you call it by a slice. Not really. Yeah, it is. Yes. Slice. Oh, yeah. Again, I have to be careful, because if I learn that this is a slice, then I'll be calling it. I would keep calling it a slice. But yeah, it makes sense. But would I be able to just write it right now if we deleted this? Probably not, because of all these syntax decorations with the pipes and the double indexing. The logic itself, yes. This one, self curly brackets dot data equals undefined, so it sets the data to whatever it is in memory and then overwrites it. No, I wouldn't be able to, but I understand it, and that was kind of the point, seeing a lot of examples and learning by examples. The type of function parameters can also be inferred by using any type in place of type. Type of can then be used on the parameter. +1 takes an unsigned integer with the value 1 and adds 1. Return type is type of X. So it will return a type of, any. But what if this type you give it doesn't support the plus operator? So right now this will work, yes. But if I give it something like this, I wouldn't expect it to be something like this. Can I compare strings with double equals? Okay. But one thing I can do is write it out. So I think I would be able to do this. I still think it would be broken. That's for sure. Because doing like this would probably work. Yes. Everything passed. But again, there were no output. Why is there no output? Clicking it again, there's an output. But if I do this, yeah, exactly my point. You cannot plus this. So this was a good negative test. So you can use any type, yes, but if you do something in here that isn't supported by that type you give it, it will break, and probably it looks like it would break at runtime, right? Cannot format slice without a specific specifier. Cannot format slice without a specifier. Or is it just that it can't output it? Maybe I'm concluding the wrong things here, and that's why I would really like some comments to help me understand this if I'm just stupid. Again, something in the chat and I have no clue how to remove it. It says that I should just hover over the chat and then I should be able to, a pop-up should appear to allow me to delete that message. But the only thing I can do is reply or pin the message. I can't even click to reply. I can click the message. I can click the name. I can follow, whisper, invite. I can ban, timeout, warn, messages. Yeah, but I can't remove it. And I really like to remove it. But okay, I'm just gonna clear the chat then. And it's cleared. Yeah. I really like to be able to just remove messages that shouldn't be there. And he's banned. Yep. I would have to go through the, what's it called? The stream manager layout and see how I delete messages that are unwanted. Let's take the last part here and call it a day. Comptime also introduces the operator ++ and asterisk or multiply for concatenating and repeating arrays and slices. These operators do not work at runtime. This we've seen before. So that shouldn't come as a surprise, I guess. Double structure equals probably defined somewhere else. We're just gonna call it equal one. Let's run this test. That worked. This one worked. Let's look at this pattern. We have unsigned 8 bits, and we have these two informations. We're gonna repeat it 3 times, so we get it 1, 2, 3 times. Equal 1, that compares mem equal. So this is mem equal. So we get a pointer to the memory, and the memory is equal to the new layout or the new array that we create here. But this doesn't work at runtime. So if this was a variable, this wouldn't work. Is that what he's saying? Or he, she, somebody's saying? But that worked. Let's see what the ++ notation does. We create an array of 4 unsigned 8s that's undefined, so we don't set it to anything. And then we do y equals x as long as it is. So x and y should be the same now, right? And we do the same for a and b, just a bigger one. And when we make a new, oh, so we can concatenate this. So these two arrays will be concatenated and we get the new length. We have no data in there. But I guess that we are allocating a new array somewhere and just copying the information, right? It's kind of the same thing we do here. Create a new allocation and we stuff 3 times this amount into it. Makes sense. But what if we make some variable called val tests equals 1, and just to make sure that the compiler uses it for something, plus equals 2, and we put this one into val test. Does this still work? No, it does not. Variable of type comptime int must be const or comptime. This is not comptime. So what here is demanding the comptime is this one. Because nothing here says otherwise. This is a comptime int, yes, but as soon as I touch it, it won't be, right? Then it can be a const. Then we don't need this because we are using this. And it fails. Ah, of course it fails because now the value should be 1, 1, 1. Yes. So this would fail. No, it still works. So I'm having a bit of an issue understanding the comptime keyword, because at some point it sounds like this needs to be known at compile time, yes, but the value I give it here, of course this is a const as well. Yeah, brain is fried for now. Have to get to work as well, so I will stop for today and we will maybe go over this again, and not necessarily this one, but jump back to the comp time and really dig into that one. But I also want to go through the rest of this so we can start on the standard library so we don't have to do everything ourselves. I hope that the standard library contains a lot of the things that we will need when we start doing some projects. So for now, I would say goodbye, and we have, as always, I'll upload this to YouTube and you can comment there, and please help me understand the stuff I don't, and enjoy laughing at my incompetence in learning this language. So until next time, Have a great day. Bye.